Hey guys, before we get started with today's PerfBytes episode, here's a word from our generous sponsor, Flood.io. Imagine your load test plan runs great with just 10 threads, but now you need 100,000 users. Distributed load testing seems like a good idea, right? But now you're wrestling with out-of-memory errors and blocked RMI ports, and your load generators outnumber the target servers for JMeter. You are throwing knives in the dark with limited feedback and Mandralic reporting. Say hello to Flood.io. Launch Flood test using JMeter or Gatling, view and share test results in real time, scale out your own grid across the globe in minutes. Flood.io, distributed load testing for everyone.
It's time for PerfBytes.
What the is PerfBytes?
The fourth square meal of the day. Don't bookmark PerfBytes. Waffles, microwave ready. Blobbity blah, blobbity blah.
Add nutritional value to your brain.
It's time for PerfBytes with your hosts Mark Tomlinson and James-Pulley. PerfBytes. Whatever.
Hey, it's time for PerfBytes, and I am I'm working at optimal mode today because there's a lot less sunlight in the late, because it's late in the season, so there's not that much daylight out now, so I can get a lot more work done. Because it's just there's nothing else to do really outside. You just have to stay home and work on your computer and stare at the screen, and that's how the holidays go for me. And so welcome to PerfBytes with myself, Mark Tomlinson, and my lovely host, co-host James-Pulley. James, how are you?
Mark, it's 10 days from Black Friday.
Black Friday, yeah.
Yeah.
That's why I'm working so hard. I've been staying up all night, which it doesn't really. I could work somewhere like in the North Pole where it gets really dark and the sun never comes up. I would just work all the time.
I'm fully caffeinated and staying up 48 hours a day now.
Yeah. Okay. Just try to relax. Hey, James, did you know we have a special guest host with us?
I did hear that. Yeah.
It is exciting. Alon, are you with us? Alon-Girmonsky from Blazemeter.
Yes, I am.
And where are you right now?
I'm actually in Israel.
Yes, but it's really nice there right now, right? You could go swimming.
It will be a bit cold, but it's nice. It's it's a perfect autumn weather. No, not too hot, not too cold. It's kind of the 2 months of the year that are perfect.
So, welcome to the show. We're glad to have you. Today's topic, we're going to talk about balancing the load. Balancing the load. Like if you're putting a bunch of bricks in a wheelbarrow and you put too many on one side and then it tips over. So then you have to balance. Is that, James, isn't that right? That's what we're talking about?
Exactly, Mark. And, basically my life is out of balance right now because I'm spending all my time working on issues related to Black Friday and I have no social existence and things of that nature. And you can see what kind of problems this causes when your life is out of balance and how your application's out of balance as well.
Alon, I think we're both wrong. It's not wheelbarrows or quality of life in social life. So what are we going to talk about today, Alon?
I think load balancing and load balancing. You first need to practice this in life, but I guess
I guess I'm a little bit of a failure at that right now, guys.
That's right. There you go. All right. So before we jump in to your big IP straight through the front door of your website, James, tell us what's going on in the performance news.
Well, Mark, we've changed our news format just a little bit beginning this week. We're going to concentrate mostly on industry news, and we're going to start off with something from Apica. Apica has announced its next-generation load test portal, Apica Load Test. It's now fully integrated with their proxy sniffer product for script development, has a simplified interface for testing setup and reporting, along with richer on-demand support. And for more information on this, please turn to apicasystem.com. We'll include a link on our website post-show. On the scalable side, for the NoSQL crowd, the latest stable version of Apache Cassandra is out in the wild, version 2.0.2. For more information, please turn to cassandra.apache.org. Continuing our infrastructure news, the ever-popular Squid caching appliance software has been updated. The latest stable release of this popular caching solution is now at 3.3 and available for download from squid-cache.org. On the LAMP side of the house, we have some PHP news. Updates on both the 5.4 and 5.5 branches have been released. 5.4.22 and 5.5.6 are now available for download and integration into your LAMP, WAMP, or WIMP stack application. Mark, why do I feel like I need a cheeseburger?
You do. I will gladly pay you Tuesday for a website built today.
Head on over to php.net for more information. And now I would like to pass it off to Alon for some announcements on the blazemeter front. Sir, go right ahead.
Thanks, James. Thanks, Mark. I would like to update you on two awesome new features in blazemeter. First, full integration into AWS CloudWatch, where you can load test your application and get all of the CloudWatch data hand in hand with the load testing data. So that's pretty cool.
Yeah.
Second new feature is complete visualization of real mobile devices connected to real mobile networks during the actual load. So you can actually pound your backend and see in real time in a video how your device, what is the user experience over your real device.
Yes. Do you actually, can you simulate a guy standing there saying, "Can you hear me now? Can you hear me now?"
What about, can you simulate dropping your phone off the counter?
And breaking the screen.
Exactly.
I'm saying be careful because you may actually see this, what you just asked in the next beta release.
In the next beta release, that's right. Leave it to James
cool.
and I to come up with the most important features that I'm sure performance testers really, really, really want. Okay. Thank you, guys. The news, great stuff happening. Let's talk about load balancing. And, if you spend all your time just testing in the lab and all you've done is just, set up the systems, you probably don't have any of the security. You probably don't have a real network set up. You just plug daisy chaining a bunch of old 3Com hubs together to try to get the load working. Actually, when you start doing work in load testing out in a more sophisticated real system outside the firewall or a very sophisticated lab, you're going to end up running into running through and into around over a load balancer. So this is a very challenging thing. And Alon, you and I were just talking about this. Load balancing is mission critical. You brought this up. Why, in your opinion, is the load balancer, a mission critical part of the architecture?
Well, first, it just is. It's consider that the load balancer is usually the first mile of your application. This is where everyone, goes in, kind of the front door of everything. The second thing is this is a component you have less control of. Usually it's something you outsource, you buy, it's an appliance. So if something goes wrong there, you're in trouble.
Yeah. Well, and I agree that it is the front door. It's where if you screw up the load balancer, the end user's experience is going to be completely screwed up. And if you have any agility also in your enterprise from a mission critical standpoint, let's say you're going to move traffic geographically and say, well, let's shut down these zones and put up a bunch of VMs on this other area over here. If you don't have a way to smoothly move the load around the globe or around the data center, you have no flexibility and no agility at all. And that's where, frankly, I think IT gets a bad name because we're like, oh, I can't move your load around, So load balancers become mission critical, not just for the web traffic, but for IT operations as well. Would you guys agree with that statement?
Yes.
Very much so.
Well, thanks. Okay, so we don't need to talk about it anymore. So this is why it's important that it becomes, a topic for our show. So we definitely want to cover some key things about the challenges for this. But before I go into that, let's finish this up. Alon, you brought up a couple other points about how a load balancer does more than just load balancing.
Yes, I did. Load balancer, other than doing load balancing and being challenging as being a front door and something that less of, it also brings some cool stuff that you didn't plan to, like in terms of security. It's harder to hack your machines because you first need to go through the load balancer, which is kind of cool. It's kind of an extra layer of protection. Also, I guess most of us and all of us should use an SSL enabled website. Using a load balancer, you can kind of offload the SSL work, because if you have an SSL enabled load balancer, then your servers can be, I wouldn't recommend it, but they can be plain HTTP.
If you need them, yeah. So if you have nothing sensitive on some of those transactions, you can remove the overhead. Of course, you can also put SSL acceleration cards directly in a server as well, right? I mean, you could get SSL acceleration, but yeah, a load balancer can also offload some of that other infrastructure activity from the logic of the application itself. James,
we've effectively covered a lot of the reasons for load balancers. I mean, they're critical. You don't want to saturate any particular node. The load balancer helps to address that. We've added a measure of security by placing this in the DMZ, so you can't get direct access to a lot of machines in a bridgehead mode. I mean, those are the most common reasons, is both security and also just for the loads. You just don't saturate. I mean, those are the two balancing acts there.
Yeah, exactly. So those two main pieces. Let's get into our sort of the next part of the conversation we were having around. One of the essential ideas is this word balancing. And
Mark, can I do this one?
You can talk about distribution.
Okay. So here is something that really irritates me.
Oh dear.
Not so much distribution schemes, but the fact that people will unbox something, put it in the rack, plug everything in, and then not investigate which distribution scheme is best for their application and their user model.
Yeah, if there's one video you should watch from your load balancing vendor in the cloud or a device or appliance or whatever it is, the one thing you should learn is how you're actually going to balance the load. Now, Alon, what's the most common one that you see with the customers, especially testing in the cloud, which is some of the newest stuff? What's the most common scheme you see?
Yeah, I think the most common is sticky by, usually by cookie and by IP. The least common is obviously round robin. So,
and it's the least common, but it's almost always the default, isn't it?
Yes.
So yeah, out of the box, it usually doesn't support SSL, doesn't support sessions, like a session state in the application. Just out of the box experience with most load balancers is either no distribution scheme, which means they force you to set it up, or the default option is just round robin. And to a lot of network administrators that may be good with logics of routing and setting up the IP schemes and DNS and all that kind of stuff, but they don't really understand the characteristics of load at the application level. I mean, these are layer 2 guys. We're talking layer 7 and above. So round robin sounds great, sounds really simple, and we all like simple things. But as Alon said, it's not usually the one that's going to work for your application, because most applications nowadays have sessions, and you want basically to keep the traffic that comes in from the client to get routed to one of the servers, and then probably establish a session on that server. And let's say you have 10 VMs or 10 web servers or 10 app servers. You're going to basically set up your session on one of those, and it's really efficient if the rest of your processing for the next 20 minutes stays on that one server and doesn't get jumping around. So if you have 1,000 people coming in, how they get balanced across the nodes, that's the benefit of the load balancer. And let's say node number 10 goes down. What happens, James?
Well, if everyone's been directed to load number 10 or node number 10, simply because it's the default, you're pretty much hosed. That's why you need to investigate these other options.
Right. So so the sticky session one, if you don't have, Alon, one of the things you mentioned, the sticky session, if it does by session, you might have to have some session state replication between the servers on the back end, right?
Usually sessions are kept in the database, right?
Could be.
So
Yeah,
you have, yeah. But going through different, it all depends how perfect or synthetic your application is. If there are no states other than in the database, you may be safe. But if your server at some point stores something and you kind of lose the node and move to some other node, then you basically start from scratch.
Yeah. And that's costly. Even if the app had good error handling and recovery from that, it's costly to reestablish that session versus smoothly, continuing, right?
Yeah, obviously it will affect performance, and if you have any information stored on that node, then you'll probably need to rebuild it from scratch.
Right.
The idea is to, in a perfect world, to keep each session on a certain node and to balance the sessions on number of nodes.
Exactly. Even if you're still doing sort of round robin, the logic of just sort of going to the next available node, but having it be sticky means every call through the load balancer is, if it's sticky on node number 3, your session stays on number 3. But if the next user comes in, they're going to go to node 4. And the next new session comes in, they're going to go to node 5. So there's nothing inherently wrong with round robin. It's just, it's usually not that simple. It's
except Mark, what if node number 4 has got a lot of people stacked up on it because they haven't left?
Well, what if there's a heap problem on on node number 4, and node number 4 is running really, really slow? You don't want to put punishment. You don't want to pound that server even more. You want to actually, a load balancer can be smart enough to say, I'm going to give node number 4 a little break. I'm going to skip it and go to the next one.
Exactly. And that gets into these alternate schemes, such as a fastest response time, whichever one is coming back faster.
Mm-hmm.
We know that that's lightly loaded. We can put some more there, put some more load to that one. Load based, if your load balancer is smart enough to be able to look at the finite statistics for CPU, disk, memory, and network on where it's balancing to, then it can put it to least loaded.
Yeah, that's a cool idea, actually. Like, you're combining performance monitoring with the logic to decide which node is the healthiest and it has capacity.
And it's usually using like the load index for the operating system for that.
Yeah.
And then you have simply least recently used. In a caching mechanism, the least recently used we would throw away. Here, for load balancing, least recently used means it's probably got the freest amount of resources, and we can just send something downstream.
Yeah, it's sort of like the redheaded stepchild that is sort of left over in the corner and no one talked. Oh, well, no one's talked to you for about a minute, so let's give you some. It's very compassionate. I'd say it's a sympathetic load balancing kind of thing.
You're not saying this is a pity load balance, are you?
I'm going to that's my new thing. I'm going to call it the pity scheme. Alon, as people take those steps to implementing, they start with a round robin. When you think about testing in the cloud from a blazemeter perspective, with your customers, they're usually jumping on with no sticky session, and almost immediately they have to get sticky session when they start doing some testing.
In Amazon, I think by default you get like a sticky cookie sessions, but you have various alternatives to choose from.
Mm-hmm.
For example, Amazon provide you can, bring your own cookie session, because again, you will want the same user to stay on the same node,
mm-hmm.
right?
Yep.
But if you are unaware of what cookie means, kind or if you have cookies, etc. So they offer their own cookies to kind of enforce stickiness.
Yeah, and that cookie has nothing to do with your app. It has to do with the load balancer by itself, right? It's just a tracking mechanism.
Yeah, and exactly. It's adding another cookie. Not that it's that bad, but Amazon are adding their own cookie to the jar of thousands of cookies.
Yeah.
Every one of us have it on their machine.
We'll be right back after a word from our sponsors. Hosting for PerfBytes.com has been provided by NewCo, New Centers of Excellence in Performance Engineering, PowerTest Professional Services, The Script Farm, LoadRunner by the Hour, Videratech, Cloud Architect, and No Load Test. For more information, go to www.newcoe.com or call 703-856-8187.
Right. So this brings up a good point, that at least for me, the majority of my testing of load balancers, and I'm a big F5 Big IP fan, but I've tested Cisco Ace, I'm an old Altium stuff, even just the Windows clustering load balancing capabilities, which used to be really, really bad, and actually just because they were new, and they've really worked out a lot of the kinks in the Microsoft world. But there's a lot of different options you have in that. When it comes to actually those are all appliances or apps like in the lab. Now, in the real world of the cloud, as you're mentioning, it's a whole different ballgame, and it seems to me, correct me if I'm wrong, that like load balancing, the options you have with the cloud providers like Amazon's Elastic Load Balancer, it's not as sophisticated as like where these old on-premise vendors have just come up with amazing configurations. It's simplified, which is a good thing, but you kind of have to know what are your options when it comes to load balancing in the cloud. So maybe give our listeners some idea of, what are other ways to work with load balancing in the cloud?
Yeah, going virtual, meaning going to doing like elastic load balancing or load balancing in the cloud, you have to understand what it means. It's not only about round robin or being sticky or not. Mm-hmm. Let's say another example is changing IPs. For example, take Amazon's ELB. The Amazon ELB, the IP of the load balancer changes, and this is an issue, especially if you're testing the load balancer. Because again, I gave an example earlier. How did we find out about this new cool feature of Amazon of the changing IPs? That many customers actually pounded their ELB, and at some point they got permission denied. Right. The fact of the matter is that they were testing already someone else's IP.
What was that? You mentioned this before, and it still freaks me out. I'm like, you'll be testing along, and if you're not paying attention, all of a sudden your load is hammering. It could turn out to be a denial of service on somebody else's system.
Yeah, that's right. It's very easy. Get the IP. and pound it and see that at some point someone else come up and say, who's that, who's doing that?
Alon, I do see your point that if you're going to have a load balancing schema in the cloud with full logical assignment, instead of using the IP address, use the logical name of the host. So when the IP address underneath changes, you'll get automatic reconciliation and be redirected appropriately. Am I paraphrasing that appropriate?
Well, if you're using a normal browser that does minimum DNS caching, you're right. A normal user will not see the DNS change because every time it goes out, there will be a DNS lookup, right? Yeah. But there is no way in Amazon, because you get only a CNAME, and you have no control. You cannot assign unless they came up with some new feature, but I don't think so. You cannot assign a dedicated IP to the CNAME of the DNS.
So what would you edit in the script to actually detect that? Could you do anything?
If you're using blazemeter, you're safe, because we've identified this a long time ago, and we reduced the DNS caching to close to nothing. Only to avoid this. And it's also, in terms of testing, it's more realistic. Yeah. Many guys that do testing, they do not care about DNS caching, but at many times, one of the points of the load is on your DNS, and therefore we actually check the DNS each and every time. So if it changes, we simply follow it.
Right. And as long as you're not setting it to 0, where you're adding overhead to every call, but you're setting it to something reasonable, could be, depending on the session time, it could be 30 seconds, could be a minute. That's probably reasonable. There are some interesting things you can do to sort of make up for this kind of dynamic IP stuff in cloud-based, at least elastic load balancing in EC2. And by having multiple load balancers and sort of doing DNS load balancing, this is something you can do with sort of any load balancer from a DNS perspective, right?
Wait. Let's go back a bit.
Okay.
Changing IPs, it's not a bad thing. It's actually a good thing.
Yeah.
In terms of testing the ELB, it creates a challenge, right? But the fact of the matter is that a load balancer is mission critical. It is connected to your DNS.
Right.
So if it fails, basically you are in trouble. And one of the ways to overcome this is by having 2 load balancers and having the DNS load balance the traffic, because an average DNS is also a sort of a load balancer.
Right.
And I think this is a good point, a good time to bring up content distribution networks, Akamai and equivalent. This is exactly what they use to manipulate which node a person goes to for caching of their content.
Yeah, so they're
essentially load balancing the internet. They're using local DNS manipulation to send Mark to a node in Pennsylvania for his data.
Wait, I don't want to go to Pennsylvania. It's closer to go to New Jersey.
Well, okay. Maybe you have option number 2.
Yeah, I want to go to New Jersey. Alon, this is what you're talking about, right? So this is actually using DNS load balancing in conjunction with other dynamic IPs for ELB, right?
Exactly.
And does this happen a lot? I mean, is this something you see as a common large system, especially globally distributed system, I'm imagining?
No, actually, load balancer are usually a reliable, equipment. So I do not see this quite often. But consider you have a mission critical device in your path that can go bad. So you need some way to overcome this. And I can say that not too many people think about this.
Yeah.
But you should.
Yeah.
Also, by the way, if you're using Amazon ELBs, because Amazon are amazing and usually are very reliable, but even ELBs can at some point go bad. And why not have like 2 running in parallel, load balanced by DNS by themselves?
Yeah. Now, the perception, I have to say, for some folks that aren't aware, is that by layering and layering and layering, you're actually always, every session is going to have to go through these layers in order to resolve what they're doing. And that when we're talking about addressing, and which is knowing the difference between RIP and sort of route D, right, is once you put it in place, the session goes very, very fast. It's not like you're adding layers and layers to the architecture. You're just talking about resolving the name and then continuing your session with resiliency, right? I think that's a key.
Correct. That is, it's you take the cost on setting up the initial connection.
Yeah.
And there is a caching effect that takes place. So if you establish a second connection, it's generally going to use the same IP basis for connecting as the first.
Right.
Your session may be different. Your OSI layer 7 session may be different, but your IP session, your layer 3 and layer 4, you're going to be virtually identical for any given individual host.
Right.
Host next door could be completely different.
Right. So, Alon, putting all these things in place, to some people might seem like, wow, there's a lot of complexity there. But actually, it's very simple steps to making sure the resolution is correct and the load balancing architecture is resilient.
Yes, it's all about architecture. But once you did the right architecture, it's very fast. It's the decision of which load balancer to use according to the DNS, and then which node to use according to the load balancing scheme. It's a one-off, usually very fast, several milliseconds, but from that point onward, you do not visit the decision tree again. So it's pretty fast.
Yeah, it's pretty fast. Excellent. All right, so we covered a kind of the intro part of load balancing, and of course, James, it's towards the bottom of the hour.
I'm ready.
Hello, PerfBytes listeners. It's your old friend Satan here. It is with great esteem that I'm proud to introduce this week's edition of The News of the Damned.
Can you dig it?
And there is that screaming. The guy screams every time because he's being punished by an outage website. Alon, it's Satan again introducing.
Okay.
I'm still shocked.
You're still shocked, aren't you? Yes.
A bit.
So I guess this will be kind of the charity edition of News of the Damned, and you'll see why in just a couple of moments. We're going to start with a superhero crashing a website. I don't know how much play this particular story got outside the U.S., but San Francisco kind of turned its gears for the day into becoming Gotham City for a kid battling cancer in the Make-A-Wish Foundation.
Which was pretty cool.
It was very cool. A young gentleman, let me see if I get his name, Miles Scott, became the Bat Kid.
The Bat Kid.
For the day, Bat Kid. And he was able to go on some crime-fighting missions, including rescuing a woman tied to explosives on a cable car, catching the Riddler as he robbed a bank, and stopping the Penguin in his attempt to kidnap the San Francisco Giants baseball team mascot, Lucille. So even the Justice Department got involved and prepared an indictment for the arrest of the Riddler and the Penguin. So, I mean, this was an amazing effort on the part of Make-A-Wish to make this kid's life better as he's battling cancer. And as the day went on,
news traveled fast.
More and more people were going to the Make-A-Wish Foundation website. The website went down, and we don't want this particular website to go down. It's taking donations for a good cause.
Yeah.
But, you know, according to the Independent in the United Kingdom, the charity received so much attention on Friday. As the day played out, the website crashed, and Make-A-Wish was left apologizing to supporters for the technical difficulties, which they blamed on increased traffic and a few troublesome villains.
The Riddler.
The Riddler.
It could be the hacker. Could be a new Bat villain. So in this case, these guys, they're not unprecedented. They're a very popular charity, right? Make-A-Wish Foundation. But again, these guys would benefit from an elastic capability because, they're popular enough where they can afford the infrastructure globally. This is halfway around the world from the UK. Alon, any advice to them if they're already in the cloud?
I think it's pretty obvious. I think that in these kind of scenarios, everyone should kind of contribute, and I would love to contribute in this kind of scenario. I think it's pretty obvious what you need to do to make this site scalable and bulletproof, meaning
you
you
use the
can
word
make
bulletproof, particularly from villains, fighting villains, right?
Well, yeah, but hackers are not really villains. So I don't think any hacker would kind of
cracker
this,
person,
this
person that's cracking software. Yeah, exactly. I'm with you. All right, James.
So headline number 2 is, even though all of our children are above average, we can't give, don't you know?
Oh yeah, sure.
Yeah. This is kind of an ode to Garrison Keillor and
myself. I'm from Minnesota.
Yeah. I heard that. Yeah.
Oh yeah. Sure. Yeah.
So on 11/14 we had a Give to the Max Day, where a whole bunch of Minnesotans based nonprofits banded together under the website to take donations under GiveMN. That's giveminnesota.org.
Yeah.
And despite the 5 hours of downtime related to load, donations totaled almost $17 million. The site went down at 1 p.m., was back online by 7 p.m. But just imagine the opportunity cost for that person who's sitting there and said, I want to donate, and the site was down. Will they come back? Human studies tell us that most of those people are not going to come back and redonate.
Yeah, but I got to say, in Minnesota, between 1 p.m. and 7 p.m., I mean, for 2 hours, you're just taking a nap at your job, even if you're working at the plant or ice fishing or whatever it is you're doing. You're sleeping from like about 1 to 3. And then at 3, you wake up and you fill out your paperwork to just basically describe what you did in the morning because you've only slept since lunch. And then, so that takes you to about 5, 2 hours worth of paperwork. And then you're in a commute, especially if you're in the Twin Cities area, you're going to be commuting for about 2 hours. And of course, stop off at White Castle. And then you finally get home around 7, and then you can get back on the website and give. So it could be that whole afternoon area there is, not as profitable as you might think there, my friend.
So if they just put up a sign, we're busy, go take a nap, it would have been okay.
Yeah. Hey, have a lefse and see you at 7 p.m. Would have worked fine for them. All right, go ahead, James.
Okay, headline number 3. Kiwis make good jam.
Okay, now this scares me. Because you say kiwis make good jams, and I'm thinking Soylent Green.
No. I'm thinking like kiwi fruit, and it's kind of a play on the website going down. And the
actual kiwi fruit.
Yeah. So
Okay.
the in New Zealand, there's this website called the Wandering Palate. It's for foodies and stuff like that.
Right.
And its website crashed recently due to an overload of traffic. Apparently, what brought down the website was its publication of the Best of 2013 roundup. Evidently, the Kiwis are a couple of months ahead of us. They've gone into 2014. They're publishing their Best of 2013.
Yeah, because nothing is going to top what happened in 2013.
Exactly.
It's only November.
Maybe they have a corporate year or something. Who knows? So its article on the Best of 2013, plus specifically the article on the best meal of the year at the Martin Bosley's Yacht Club restaurant in Wellington.
Can I get an invitation? I want to go. I will go.
These two things together, load for these two things took out the website. To me, this says CDN all over it. And so my advice to the Wandering Palate is hint for next year, make your best investment for 2014 a contract with a CDN provider who has presence in New Zealand and Australia.
Oh, and I think switch to static content. They probably had a dynamic content. If you did static content, cache it in the CDN, they'd be golden. They'd be perfect.
They'd be golden. They'd be golden. Exactly. And our last story comes from a provider in India, Senthil Kumar.
Oh, thank you, Senthil.
Yes. Yeah, we call this, because we have to have something related to tickets in every News of the Damned.
Yes.
Ticket time. Oh, ticket time. So from the Times of India in Pune, facing a mad rush to buy a limited number of tickets for Sachin. Boy, I'm going to butcher this name, and I'm so sorry.
Sachin Tendulkar. I bet it's a second Tendulkar. Alon, what do you say? Sachin Tendulkar.
I would vote for Sachin Tendulkar.
Yeah, I think his emphasis on the DU.
Okay. So basically, here's a man who is at the peak of his game, and this is his last test as an athlete.
That's right.
An online ticket site, Kayazunga. This is the first time Kayazunga has been in our News of the Damned.
I don't think you're saying that with enough zest.
Kayazunga.com.
Perfect. That's
crashed
excellent.
Before it could even start the sale of tickets.
Wow.
So there's only 5,000 tickets available to the public.
Okay, so wait a minute, James. It crashed before the event was available? So
Well, here's what happened. So starting about 11 a.m., you saw a whole bunch of people coming to the website. They knew tickets were going to go on sale. And as a result, when it came time to release the tickets, the site was overloaded already. And so they had like 19.7 million hits.
So it's like
in the first hour.
It's like pre-event anxiety that brought,
exactly.
Oh my God.
So it's like people hitting F5. They're waiting for the shoe sale to start.
Yeah, exactly.
F5. And of course, what's happening here is clearly there's no caching set up and no CDN provider. So all these hits are coming back to the original source. I mean, normally you hit F5, unless you hit Control F5 to reload all the resources. F5, it's going to reload from cache whatever it can. So you're going to minimize the traffic going back and forth. Here, you clearly had people just going.
But this is the point, right? I mean, these guys want the latest content, so they don't want. They'll actually they may configure their browser for no local cache. So even F5 is going to send a full request.
But Mark, there are certain elements you can cache. Like you could cache style sheets, you could cache graphics, you could cache JavaScript files potentially, but maybe not or set specific caching on the page associated with tickets for this event to have no cache on it.
Wait a minute. What if the reason we keep seeing so many ticket sites end up on the News of the Damned is because people intentionally turn their browser cache to 0 so that they don't get fooled by the client, and they do 100% load every time they hit F5. And
you can bypass that user behavior by having a CDN layer, which is still caching a whole bunch of that content.
Agreed.
So you're going to be hammering the CDN layer and not hammering your origin server until that one page goes live.
But I wonder if that's the behavior that keeps bringing tickets people into News of the Damned.
Potentially so, doing a Control F5 and then just sitting pounding it.
Totally, yeah. Users will figure it out, especially when it's something that they really value, like being able to go to Kayazunga and see Sachin Tendulkar's 200th last test.
Yeah, so I think this is an example where very, very specific management of caching of objects combined with the CDN layer. If you had to have that, you could have it with Squid, which we mentioned earlier today.
Yeah, new version.
And so you could manage it all in-house if you wanted to. But, this 19.7 million hits in the first hour, there's something oddball on that statistic, and that really says they're not managing that effectively.
Yeah, I agree.
Cache.
Yeah. It's the first time ever we've had some evidence that there was sort of pre-event anxiety that brought the site down. That's very interesting. Very interesting.
That is very interesting.
It's time for a perf rant.
Hello, fellow performance engineers. This is Dan Bartow from SOSTA, and today I'm going to rant a little bit about load balancers. After 7 years of testing applications in production, we've seen the same 3 repeat offenders year after year after year when we look at all the tests we've run for all the different customers. And number 1 for 7 years running are load balancers. Load balancers are breaking application architectures and preventing these e-commerce sites from getting to their peak traffic in anticipation of Black Friday and Cyber Monday. So this is a topic that's really near and dear to my heart, because when I was managing engineering for TurboTax Online, I'd actually witnessed a few catastrophic events in our production environment that all boil down to load balancer problems. These things are servers themselves. They're, in the case of F5 load balancers, the big IPs, they're running a kernel. They're running a version of Linux. They've got multiple processor sets in them, one for just running the operating system, another for handling the load balancer and the SSL transaction component of the device. They've got multiple network interfaces. They've got memory. They're bound by all sorts of different things. They're amazing devices. They're capable of some really complex things. You may not know, but the F5 big IPs are capable of no less than 20 different load balancing algorithms. You might know round robin, which is where the load balancer just passes connections across the web server or app server pool, but they've got many others like least utilized and least connections, and these load balancers can actually tap into the web servers and the app servers that they're balancing across and look at their health and make decisions for load balancing across them based on how heavily utilized they are. So they're really complex devices. The biggest bottleneck that we see, and people don't realize this, is that on the load balancer, it's not normally CPU that pegs these things out, although certainly you got to watch CPU as load increases on them, but it's actually SSL transactions per second. It's a licensing thing. It's not a hardware thing. It just comes ready to handle 100 concurrent. And one of the things that bit us at TurboTax Online was that we had like 1,000 SSL transaction per second license, And what happens when you hit this limit is it's pretty ugly. It's actually not very graceful. Once you hit 1,000, there's a little bit of a grace, a little bit of a queue in there where, let's say, it might process 1,100 or 1,200, where it queues up a few, and these transactions that are processing through just have a slightly more increased response time. But actually, beyond that, if you push it much further, connections just start dropping and timing out. Really ugly. We were all surprised to find that the things that we were seeing in production that were catastrophic events were actually solvable by just uploading a new .txt license file from F5, and all of a sudden, blam, our load balancer had more capacity. Of course, we had to pay for that, and they license and pay for charge you for those licenses, but it was just that easy. Because once we started looking at the device, we realized CPU looked okay, we realized memory looked okay, bandwidth utilization looked okay. But once we started looking at the transaction charts, we noticed this funny chart on the SSL transaction chart where it just went up and up and up to 1,000 and flatlined. So classic, but nobody had been looking at it. So anyway, these guys, now we've got this whole new breed of software load balancers, right? Whether it's Amazon's ELB or HA proxy. And I applaud the move towards software load balancers, but as with any new technology, you find that people slap them out there and they take it for granted. Just like the hardware versions of these things, you can't put a load balancer out there, a software load balancer, and just configure your web server or application pool and flip on round robining and not look at the thing. You really need to test to scale and make sure that the load's getting distributed evenly. Here's another thing about load balancers. They will take servers out of rotation. They'll do health checking, right? And the health checking component of it, we already talked about the bottleneck pieces, right? CPU, memory, SSL transactions. Well, health checking is a whole nother area on these devices or software implementations that are really, really important. Health checking, for instance, if a server doesn't respond, a default health check might be 3 seconds. So if a web server doesn't respond to a simple TCP connect within 3 seconds, the load balancer will pull it out of rotation. Sometimes that's too aggressive. Sometimes that's too lenient, right? Sometimes it's too lenient. So what might happen is under load, your application might slow down, and that might be natural and expected. But then all of a sudden, the load balancer is rapidly pulling servers in and out of rotation because they're not responding within 3 seconds. So the health checking component would be the next thing you need to look at. Once you're monitoring the performance and looking at your transaction throughput and your bandwidth and all the normal KPIs, then go on and look at the health checking, because we spent weeks and weeks tuning the health checking as well on these devices. But don't just put these load balancers out there and expect them to do their job. They need love, just like everything, just like everyone. So anyway, that's my rant on load balancers. I can't believe that for 7 years in a row, out of all the testing that we do, 8 out of the top 10 online retailers in the country are customers of ours. And if you just boil it down, all this testing we've been doing for hundreds and hundreds of customers this quarter, load balancers are breaking above and beyond all. So if you want, you can start a load balancer consultancy and probably go over quite well. Anyway, thanks for listening. Cheers.
All right, guys, there's a few more things we should talk about, which are very critical and specific to your experience running load test or running load through load balancers. Now, there's one that I'm going to just volunteer here. But you really forget this thing called SNAT. James, what do you think SNAT is?
Martha wasn't feeling too well a couple of weeks ago, and she was wiping her nose a lot.
Yes.
That's what comes to mind.
It could be also the past tense of snotting, snat.
Yeah.
SNAT.
Do I have that wrong or right, Mark?
Anyway, snatting is like network address translation.
Oh, okay.
So there's something really interesting, especially if you're using physical devices as your load balancers, that is key to the performance of the core of your system. And that's the ability to configure the network address translation properly, regardless of what distribution scheme. You can do round robin or all other logic is fine, but it has to do with routing traffic through the load balancer.
So Mark, this would be, instead of handing off from the load balancer, this is where you're using the load balancer as a bridgehead, like in your DMZ, and you're actually going through the load balancer for every single request.
Right. So imagine back in the day, you had, let's say, a 1 gig link going through the load balancer. So there's a front end and a back end load balancer connection. So there's two interfaces on the load balancer. and let's say they're both just connected to a VLAN, and the VLAN on the back end has your 10, 15 web servers on the back end. If you're going to do address translation, if you're going to do snatting of that, you're actually asking the traffic to come into the load balancer from the client and then get translated into, which is source address would get translated and then sent on to the target. Now, when the web server replies, it's got to send its traffic back through the load balancer, which...
So then the load balancer has the overhead of managing all the sessions and translating it back to the original client.
Well, not even that, but it actually has to move the packets. So let's say you got a 1 gig link, but you want to do, something that's 350 megabytes per second. You're like way over capacity on the throughput through the load balancer. So looking at this thing called SNAT, and it's usually on what's called the virtual IP address on the front end, where you say for this virtual IP address, enable SNAT. And SNAT says, take my client side IP address and just do the back end translation. A better, more scalable way to do this is to not route 100% of the traffic, as James said, through a bridgehead, through the load balancer, but actually kind of use the load balancer to kind of assign the traffic to a given target, one of the web servers, but then allow the traffic to continue back and forth between the client and the server. And there's some caveats here, right? So usually you'll see a redirect that so there's a little overhead in the first hit that gets you redirected to the web server. But if that web server goes down, you will get failed back over into the load balancer and then redirected to another node in the cluster. So there are some sort of operational differences between these two approaches, but if you have limited throughput on the device from the inbound interface and the outbound interface on the back end, then you might want to switch to something that's snatted properly so that the translation allows the client and the web server to communicate directly to one another. And you can apply this, within a data center behind the firewall. You could have this on large public websites where, you actually have this sort of DNS resolution. James, have you ever seen sort of a URL where it switches from being www.anything.com to like www1, www2, www3?
Absolutely. This is one of the most common failures in script development, is not taking into account the effects of the load balancer. And so when you run your load test, all of a sudden you wind up with all your load on one of the web servers in the cluster, despite whatever is coming back from the load balancer. And the load balancer handles this in a couple different ways. In some cases, they handle it as an HTTP 301 or 302 redirect. That is the cleanest way to handle this, because then you're just simply going to follow to where it's supposed to be. But in other cases, it actually hands back information to the client, which then redirects it for every follow-on request outside of the HTTP mechanism. And that's where you have to be careful and you have to be extremely watchful about what's happening in your script development.
Right. So, Alon, when this is different as people move into the cloud, they don't actually have a device with all this crazy sophistication. Have you ever seen anything similar to this sort of cloud load balancing wise?
A bit different. Obviously, cloud load balancing is very common, right? You must use it in almost any kind of scenario unless you build one on your own, right? Mm-hmm. If you build one on your own, then you can do whatever you want. But usually the one thing that kind of resembles what you just said is the fact that when you use an elastic load balancer, the source IP will be of the load balancer, right? And not of the client.
Uh-huh.
And you'll have minimum control to do the sophisticated stuff that you just mentioned.
Yeah.
But, however, the load balancer does deliver the source IP in kind of the X forward header, of the request. So you can query the request for the original source IP.
Okay, so this is very similar. You would look. I think you mentioned before. You would look in the Apache logs. You would see that the actual traffic source address is all from the same source behind the load balancer.
It will be all of the source will be of the load balancer itself. So you'll probably see a single IP, and you will not, and it will also will be an internal IP of, let's say, if you're using Amazon.
Yeah.
But if you want to see the source, you need to get it from a different place.
So that makes sense. These are good things to know if somebody's like, how does a load balancer work performance-wise? And just the truth is, there's very, very low latency on the address translation, just from a packet inspection standpoint, whether you're in the cloud or in a device or not. So enabling this network address translation, and it sounds like there's the right network address translation happening from an Amazon perspective as well. So let's talk a little bit about during a load test, then what you would do to monitor a load balancer, because it's a part of the component, it's a part of the infrastructure that you're running traffic through. And of course, it can have bottlenecks like anything else, right? A very little itty-bitty small load balancer with no CPU or really slow interface connections network-wise. You can have just the basics of a load balancer be under-configured, right? So, James, maybe give a description of like, what's the biggest load balancer you've ever tested through?
It's got to be either a Cisco device that is actually a blade in one of their larger Cisco chassis solutions, or one of the larger F5 solutions. In either case, the backplane has a huge amount of capacity. These boxes are almost configurable as routers for up to 10 gigabit Ethernet, but they can still bottleneck on the CPU.
Yeah.
If you ask it to do a lot of work for a lot of different sessions, it still has to manipulate all the IP session headers for how it gets back to the client. This gets back to the discussion of bridgehead versus handoff.
Yep.
Likewise, if you have a lot of SSL ongoing, SSL is CPU intensive. If you don't have any acceleration cards to handle that, you can overload. And likewise on RAM, a lot of these devices don't have a whole lot of memory on them. So if you get a lot of sessions and you get a lot of state information in memory, you can overload RAM as well. So in this sense, it's not unlike any other host. You've got CPU, disk, memory, and network. You've got to monitor all of these items. And something else that I like to monitor during a performance test where a load balancer is involved is I like to monitor the file size for the logs on the web servers.
Okay.
If I had an out of balance condition, it's going to show up almost immediately where I have one log growing at just a tremendous rate related to the other hosts.
Yeah.
So it's not even content; it's just size.
Yeah, and I would add to the fact that a device, if you're using a physical device, not a virtualized device in the cloud, a physical device has the core CPU from the main, usually an operating system of some sort behind the scenes. But even on the ASIC, the actual interface itself has a CPU on it, actually has cache memory. So if you're using VLANs in your architecture and you just have sort of one 10 gig input and one 10 gig output of your load balancer, you have to monitor the bytes in and bytes out. The throughput of the device itself can be bottlenecked. And you might say, you know what, we have 2 or 3 fiber connected. Like on an F5, you could have like 4 fiber channel connections in 10 gig fiber going in, but you'll have still maybe another module of 10 gig copper or even 1 gig copper. And you might say, I'm going to put one VIP on these sort of smaller copper things just to segment the traffic, keep an internal VIP separate from another one. So you'd want to monitor the actual bytes throughput, input and output on each of those interfaces, because not only the logic of the internals of the main CPU, but even the ASICs on the individual interfaces can get overloaded. Just if you try to put too many VIPs on too many VLANs into that single device. So that's one thing to keep in mind in monitoring. And as James, you point out, memory is probably the second thing I would recommend as well. Like look at the heap, look at what's happening internally, structures, caching sessions. Alon, you mentioned sort of sticky sessions. And of course, on devices as well in the lab or in production, you're going to have memory taken up by all these data structures, keeping could be tens of thousands of connection. Yeah.
And not only that, Mark, but related to session, if you have a 30-minute keep alive on a session, when the maximum amount of time between each individual page request is 2 minutes, you're stacking up a lot of resources that have to die off at some point and have to be maintained.
Yeah, it's not just about absolute memory capacity. It's about how long you have to maintain a given object or a session piece. Alon, any thoughts on how that sort of, would you monitor things differently? How can you monitor elastic load balancers? Do they have an interface to do that?
Yeah. As James mentioned, it's a host still. Even if Amazon kind of covers it as a service, it's still a host. And usually I can tell you what Amazon provides and what I would look for as well. Usually you should consider that the load balancer is still a web server. So it has all of the HTTP functionality that you would kind of monitor on your web server, like 500 or 5xx responses or permission denied responses. So on top of kind of if I were to have like my own device, I would measure memory and CPU, etc. But also what would be the HTTP error rate, right? And the one other thing that I would kind of monitor is the actual distribution, right? I would make sure that the load is distributed to all of the nodes in the distribution mechanism that I envision, meaning because you don't want to wake up and say, okay, everything went to one node and 4 nodes are sleeping there idle. You want to know of that prior to your kind of peak time event.
Yeah, you're paid for a load balancer. Are you balanced? That's a good question. And you can find bugs that way too. You can say, well, wow, for some reason this server, which is created equally, is not getting the same amount of traffic for some reason, and we'll figure that out. So yeah, just even generally, is the distribution schema actually being applied correctly? Really, really good. This has been good. We've talked about all sorts of stuff with load balancers. I think this is pretty excellent. Any last thoughts, Alon? Any on sort of generally how people should cope with load balancing in their tests if they're using blazemeter or any other solution?
The one thing that usually if one is, let me ask you a question. What is the most common problem with load and performance on a high availability, on a scalable website?
Yeah, to me, it's failure. It's just failure to plan ahead and say, well, what if avoiding a single point of failure is the number one thing that I think people miss?
Actually, for me, it is a group of individuals called ops. Because as much work as developers do and quality assurance does and performance engineering and test makes, we can do everything so great, and then we hand it over the wall to ops, and they can totally screw it up. And part of the load balancing schema is a part of this. How they manage cache is a part of this. I got to say, I'm dealing a lot with ops these days, and there's not a single organization I deal with that has everything set correctly, and load balancing is a part of that.
I can tell you from my point of view, the most common failure is simply bandwidth. And I'm serious. You would expect your load balancer or your gateway to take on, 10 megabits or 10 gigabits. And when you test it, you see you get, 1/3 of this or 1/10 of this.
Yep.
And this is usually due to some configuration or out of the box configuration that you actually didn't change. So I would say
exactly, it's those bad ops people just putting it in a rack and walking away. Sorry, I couldn't help it.
It's true. It's just, here's the default. Have a nice day. This is the way it should work, right? And it
should.
The thing is, it's never that way. To your point, Alon, it's like, there's just start with the basic math. if you do one session and you measure how much traffic, non-cached, 100% of the requests go through, what is the total amount of throughput, and sort of come up with that worst case scenario. There's no CDN, there's no caching, there's no load balancing, there's one server. We know a session requires 1.7 megabytes per 10 minutes, whatever it is, the rate. And then you can say, at a bare minimum, if let's say the CDN fails that day and all the traffic goes to origin. Let's say the load balancer fails that day and all the traffic goes to one server. Well, what's the worst case scenario? Worst case scenario is one server, one client, 1.7 megabytes in 10 minutes. And so just bandwidth wise, if you haven't done the simple math, and then you start putting in, I've got a load balancer and I've got DNS redundant to my load balancer. So I've got elastic load balancing with 4 nodes and I DNS 2 different nodes for different regions to load balance those 2 and start balancing everything across, plus caching headers properly in the CDN for static content. Then you start adding all of this to the fact that your origin server may end up, not having to serve almost anything, but you're prepared. Studying the bandwidth and knowing, what's the worst case scenario, and then work yourself back through all these layers, the load balancer and everything else, then you can figure out exactly, do I have even enough bandwidth through the front door to make sure that this works? I agree wholly. All right. Thank you very much for joining us for another episode, a riveting and fantastic episode of PerfBytes.
As always, I want to say happy birthday and thank you to my mom for tuning in. Mom is turning 2D in base 29 math today.
Yes. Thank you to James's mom. Happy birthday. And thanks always as listening. And of course, I will give my moderately intimate thank you to the sexy Irish voice of PerfBytes, Martha, for everything that she does, including snatting or snotting or whatever that is.
Today's episode is powered by old compact hard drives and Alon. It's also powered by
blazemeter-com extension, which is my love of my virtual life.
Perfect. That's it, which is the love of my virtual life.
My cloud computing life.
Your cloud computing life. Exactly. That would make perfect sense, wouldn't it? And of course, please be aware that all of the content of this PerfBytes show is protected by the same Synavia protection technology used in Sony's PS3 PlayStation from back in 2012. Of course, you can just change the date of the PerfBytes episode to get around this annoying feature.
For more information on PerfBytes, please visit the show's website at www.perfbytes.com or follow us on Twitter and the Facebook.
Of course, join us for our next PerfBytes in about 2 weeks as we enter the last few days remaining until in the U.S., the e-commerce hell ensues on Black Friday and Cyber Monday.
And of course, you can always subscribe and listen to PerfBytes podcast on iTunes. Just search for PerfBytes in the iTunes store and click subscribe.
PerfBytes is a supporter of the Software Test Professionals community of testers, and we hope to see you at the next STPCon conference, which I think is in New Orleans in April. We're also supporters of the Performance Engineering Book of Knowledge, the PBOK, and of course CMG, the Computer Management Group, and we're happy to be involved in the performance testing community worldwide via the practicalperformanceanalyst.com website. And lastly, I will say thank you very much to Blazemeter and Alon-Girmonsky, who joined us from all the way from Israel. Thanks, Alon, for joining us.
Thanks, Mark, and thanks, James, for having me.
Absolutely.
It's our pleasure.
And we'll listen to you next time, or you will hear us next. I don't know how to say that properly anymore. I guess I had 2 glasses of Macallan 18. It was really kind of...
Hey. Everybody, same bat time, same bat channel. We'll see you in 2 weeks.
See you next time. Thanks, guys. Thanks, Alon.
Cheers. Bye.